All right, here we go. So, in example 4, if I have sketch y equals tangent x minus pi over 4 plus 3. So looking at this, now I'm doing a phase shift and a vertical shift. So take a moment and see if you can identify from the equation the phase shift and the vertical shift. All right, turn to your neighbor and share what you got, because I'm going to call on somebody and I want you to feel confident when I call on you.
Great job, JJ.
All right, Nick, what was your phase shift?
Right pi over 4.
Good job, right? Pi over 4. And Humera, what was your vertical shift? Up 3. All right, to find the period length, you take pi divided by b. Brennan, what was the b value here? Not 1, right? Yeah, because 0 times x is 0. So yeah, so that's pi. Then let's figure out the asymptotes. So here's what I do to find the asymptotes in general. Take half the period plus your phase shift. To do your vertical asymptotes, you're going to take half the period plus the phase shift. So I'm going to take half of pi plus, now if it had gone left, you would have subtracted. So this is what, 2 pi over 4 plus 3 pi over 4. So my first asymptote could be 5 pi over 4 plus the period. So do you see that, but the period length is pi k. Is there one before 5 pi over 4?
Yes.
Because I took half the period, which is pi over 2, and then I add the phase shift. Oh, sorry. Thanks. Thank you. Yeah, that was pi over 4. I don't know where I did the 3. I was adding it and then adding it again. Sorry. Thank you, Mia. No, that's 3 pi over 4. Thank you. So that's 3 pi over 4 plus pi k, where k is an integer. And now this is where the table gets harder, okay? This is going to get harder with the phase shift. So my domain then is everything except where your vertical asymptotes are. So at the end, that's 3 pi over 4. So now this isn't as easy. It's not negative 3 pi over 4 because that's not a period length of pi. Okay, so can anybody figure out if the period length is pi and I had plotted, say, 3 pi over 4, what's pi to the left? Where would that land me on the x-axis?
Negative pi over 4.
Outstanding, you got it. That's negative pi over 4. Let me go over that again. DP rocked it here. So look. I'm going to go 1, 2, 3. That's 3 pi over 4. So how many ticks is pi? 4. So then if I just count to the left 4, that's exactly how DP got negative pi over 4. Well, what's halfway between there? Pi over 4. Good job. And then what's halfway between negative pi over 4 and pi over 4? It's kind of easy, right? 0. And then what's between pi over 4 and 3 pi over 4? 2 pi over 4, but we would tidy that up to pi over 2. Now what you're going to do, okay, to the right, I start with negative 1, 0, 1, but this is going to go up 3 units. So that's going to be 2, 3, and 4. Let me talk you through this one more time before we continue, because this is confusing, okay? So let me try to clear it up for you. So what you do, you're going to start with your asymptote. Okay, I think the asymptotes are the best place to start. So you take half the period plus the phase shift. So 1/2 pi plus pi over 4. So I don't know, I was adding in my head and then added it twice, but so that's 2 pi over 4 plus pi over 4 is 3 pi over 4 plus the period. Okay, in general, it's always so once you get to this point, that's the first vertical asymptote plus pi k, because the period was pi. So then, that's the end of my table, and I know that the period length is pi. So I just go backwards pi. 3 pi over 4 minus pi is negative pi over 4. Then we went halfway, and what's nice, when it's 4 ticks, just go to the middle. That's pi over 4. Go to the middle, 0. Go to this middle, 2 pi over 4, which is pi over 2. So let's do a little more counting to the right. So this one is pi. This is 5 pi over 4, 6 pi over 4, 7 pi over 4. I think that might be enough. So we have vertical asymptotes at negative pi over 4 and 3 pi over 4, and then I'm going to count 1, 2, 3, 4. Then I have 0, 2, pi over 4, 3, and pi over 2, 4. Another possibility here with your vertical shift is you could do where you make a new x-axis and move it up, but I think these are easy enough to figure out. We'll see. All right, so here we go. Example 5. Try to write down as many of the pieces as you can. Y equals 3 tangent, 3 times the quantity, x plus pi over 3 plus 1. Try to figure out your phase shift, vertical shift, vertical dilation, horizontal dilation, period. Then if you can handle the asymptote, go for it. Those of you that might be a little shaky, at least find half the period and add the phase shift. Now if the phase shift is left, that'll be add a negative. All right, turn to your neighbor and just share what you wrote down so far. That's your stretch or shrink.
Oh, okay. So it can be either.
Yeah. But because you have like a vertical shift and a vertical dilation, like I'm trying to separate where you write them. All right, so phase shift. I got left pi over 3. The vertical shift, I had up 1. I had a stretch of 3 and a shrink of 1/3. The period length is pi divided by 3. Did we get those pieces?
Mm-hmm.
All right, awesome. All right, now here's the tricky part. So you're going to take half the period, and then this is left pi over 3 to get my first vertical asymptote, my first positive. So that's pi over 6 minus 2 pi over 6, which is negative pi over 6. So the way you would write that is x equals negative pi over 6 plus pi over 3k. The problem is we don't like vertical asymptotes, the general ones, to be negative. So could we, even though that's going to be our first one in our table, that's beautiful. So the first one is negative pi over 6, but could we add pi over 3 to find the first positive one? So that's going to end here at pi over 6. Oh, that's kind of nice, isn't it? Yeah, this one's nice. So I'm going to write my asymptote is x equals, and it is an equation. And then I'm going to go pi over 12, negative pi over 12. Undefined, undefined. All right, so now you're going to have to multiply by 3 because the number out front is 3, and then shift it up 1. So this normally goes negative 1, 0, 1. So that'd be negative 3 plus 1. 0 times 3 plus 1. 1 times 3 is 3 plus 1 is 4. Okay, so you're doing 3y plus 1 is what's happening. All right, so let's figure out what to do on our scale. And I have been quite nice to you in terms of phase shifts. Like these can get ugly. These can get really bad. Yeah, number 2 might get a little tricky on the homework with that one because it's right 2 pi over 3, but the period is pi. So I think I'd go by pi over 3s on that one. All right, so here we go. I'm going to make every other tick pi over 6. So 2 pi over 6 is going to be pi over 3. All right, so actually the in-between tick that I haven't marked is really a pi over 12, okay? So I'm going to put a vertical asymptote at negative pi over 6 and pi over 6. So then if this repeats every pi over 3, how many tick marks, where would I find the next vertical asymptote? Good job. You're just going to count 4 ticks. That's pi over 2, and then you're going to see one at 5 pi over 6. So then let's put it at 0, 1. I have negative pi over 12, negative 2, pi over 12, 4. So do you see how this is, in fact, a vertical stretch of 3? So can I get eyeballs up here at the board? Do you see that? So you could, in fact, write an equation for a tangent graph. Do you see from the midline, okay, if I could imagine where the halfway is, from that midline to the next point, do you see it has a vertical stretch of 3? Do Do you see that? From 1 up to 4, that's 3 units. So there's your A value. All right, so then let's just repeat it for another. So at pi over 3, it's going to be at 1. At the one to the right, it's 4. One to the left is down at -2. Really work on your concavity. Okay, work on the concavity here. So, yeah. Elise? Did I do the phase shift? I did. When I did the asymptote, do you remember? I subtracted the pi over 3. That took care of it. But do you see, get this, the period, and it's an excellent question, Elise. So, Elise asked, did I take care of the phase shift? And this one's super interesting because this is left pi over 3, and the period is pi over 3. So do you see, I moved it actually in identical period length. So it's just like stamp, stamp, stamp. I moved it, but it was already there. Does that make sense? Okay, it was an excellent question. All right, but here's what I'm talking about with the concavity. So I will look at this on your final exam. That's where you're going to get tested on this. So up until the midpoint, it's concave down, and then it's switching to concave up. So like as you're trying to sketch this, really lean into that concavity. And if it's a reflection, it's going to go concave up to concave down. At the midpoint is where it's switching concavity. I'm planting some really good calculus seeds here. So at 2 pi over 3, so when you go to calculus, we're going to work really heavily on concavity. So that's why I emphasize it in Algebra 2, because I teach AP Calculus. So I'm paying it forward. All right.